Hello there, ladies and gentlemen. Welcome to the future. My name is Zach Gardner. I'm the chief architect at Keyhole Software, and today, a very exciting presentation for you all. One of the things that, if you know me, that you know I like to do, I like to go out and learn from other people's experiences. I want to make sure that whatever it is I'm doing, I have some foresight that I can try to get out of it. I want to go out there and learn from what other people are doing and not just learn from what they've done. I want to learn why they did it because that often is the thing that's missing in a lot of these conversations. We miss so much information on just the context around why decisions are made. And that will often mean more than what the actual decision was. So I, as an architect, there aren't a ton of resources out there for me to go and just kind of explore it. It's not like I can look at a sample code base and really understand the architecture of it. Very rarely does something like that happen. But every once in a while, there's an interesting GitHub repository that catches my eye. And today, that GitHub repository, if you couldn't tell, is Twitter's The Algorithm. Now, there are likely a lot of different algorithms that Twitter uses. Granted, they're a very large organization. This is what they do. The one that I want to spend the most time in particular learning about today with you all, kind of as we explain this algorithm, it's the one that powers their feed. When you go and you're doom scrolling on Twitter, which, shame on you, none of us should be doing. How exactly does that work? How does it pick the tweets that you're going to see? How does it mix in the ads that you see? How does it differentiate between your in-network and your out-of-network content? For some reason, maybe that's just because I'm hyper online and I really like, I don't know, LinkedIn or something. That's really appealing to me. I want to learn how it is that they did it, how they made these architectural choices. And I also have a resolution this year to make sure that I'm not repeating the same mistakes that I did. So if I look down, it's because I'm looking for your comments as we're going along. Make sure to like and subscribe. And I'm also making sure that the audio that you're hearing isn't just looped the same 5 seconds, because that was something that I discovered happened the last time we did one of these presentations. So if you're watching this on the recording and you're not on LinkedIn, you're missing out. Life is good. It's good to be live on LinkedIn. And if you don't know me, which, hopefully most of you out there do, my name is Zach Gardner. I'm the chief architect at Keyhole Software. When I architect applications, they're usually enterprise grade business to business applications. I mean, we're talking about, sort of large organizations, things that power their revenue, things that help move them forward as a company. My specialty really is in healthcare, but I do have experience in energy and agriculture and a number of defense, a number of different fields. And I like architecture because I get to see what works well in one field, what are some of the things, the unique constraints that they have, and be able to apply that maybe to other organizations in completely different domains. 80% of what we do in software, I heard this said yesterday, is probably about the same, no matter which organization you're building the software for. It's really the 20% that is unique, the unique constraints that's the part that's really exciting to me. So that's why I like to learn. I like to dig into these kind of presentations to figure out just why it is that they made these decisions. Only other thing I'll say about Keyhole. So we're based all in the Midwest primarily. We have some people, outside the Midwest. We work with companies that want to increase their revenue, that want to decrease operational costs, that want to get a competitive advantage over their competitors, and they have an idea for how to do so, but they can't find anything off the shelf to do it. That's where we come in. We get to work with a lot of really exciting clients, and I am so thankful they've given me this dream job. The only reason I am here is because we serve a need to them. So just checking my audio. And if I pause during this too, my dad's actually having a procedure right now. So I'm just kind of, checking in to make sure that everything's okay. So that said, when I approach something as vast as the Twitter algorithm, I need some way, some rationale, some framework to view it in. So I like to ask a number of questions just to get my head wrapped around this massive amount of code base to really make sure that I'm able to derive all the intelligence that I need to from it. So let's start with the question of why. Why are we going to this? Well, for starters, if you want an application that has a massive amount of scale, Twitter is a really, really good use case for it. They had, I think this is on one of my later slides, somewhere in the neighborhood of 500 million tweets coming in a 24-hour period back in 2023 when they open sourced a lot of this information, which unless you're working in high frequency trading or you're on another major social network, you're probably not going to see that kind of volume. So take it with a grain of salt. A lot of the things that they did, they had to do it because they had massive scaling challenges. But that's okay because we can still learn some really interesting things, even if it doesn't directly correlate to the exact industry, the exact business we're in. Let's broaden our minds. Let's go out there. Let's read books. Let's meet people. Let's talk. Let's try to figure out like what everyone else is doing. And probably selfishly for me, why am I looking at Twitter? Because few other organizations of their size have decided to open source their algorithm. These links, as well as this presentation, will be posted next week, Tuesday, the January 30th, I believe, if I did the math right in my head. So don't worry about, taking pictures, like this is fine. This is all going to be recorded. We're going to throw it up on the YouTube. It's totally fine. If you want to learn about how this algorithm works, the first place I recommend you go was actually their engineering blog. This was the first place where I actually encountered the fact that they had even decided to open source something. And it goes through and it walks through at a very high level what the architecture is, which gave me an okay frame of reference. I could kind of understand where they're coming from, but I needed a bit more. So there's 2 GitHub repos that they have. There's one that's just the algorithm. There's one that the algorithm that's really just about the machine learning aspect of it. Unfortunately for this presentation, I don't have time to dig into the machine learning one. So the one that we're going to be concerned about is sort of the main code base. So that was my frame of reference. I read the docs. I started looking at the code, and then I was like, okay, I need to figure out, and they didn't really, they kind of addressed this in their documentation, but now that I know what it is, I really understand, I need to know the why, like what it is that they are trying to accomplish with the algorithm. And like any good social network, they have some pretty succinct goals. They want to keep you on the platform for as long as possible, because the more you're doom scrolling, the more you're interacting with people, the more minutes every single day that you spend as a daily active user, that's how they get revenue. Now, granted, this was before the whole blue checkmark controversy came out, where you had to be able to like pay for the blue checkmark, but that's okay. The ads are still where they make, as far as I know, a lot of their money. So their goal is to keep you on the platform for as long as they possibly can. But it has to be a mix, because they know that if all they do is see ad after ad after ad after ad, or irrelevant after irrelevant after irrelevant content, they're going to pick up and leave. They have other things they need to do during the day. So they have to be able to have the right mix between showing you content that you care about, and then every once in a while kind of mixing in the ads. And we'll talk about the mixing here in a little bit. So now that we got our goal to keep you on the platform as long as possible, the problems. They have 500 million tweets that were coming out every single day in a 24-hour period back in March of 2023. I'm wondering if that's slightly more, maybe slightly less, to be honest. But it's a massive amount of transactional data that goes through their system, and they have to distill that so that when you're scrolling through your timeline, they can present those tweets to you. They are relevant to you, and it is something that is going to keep you engaged. So this is a visualization that I cribbed from their engineering blog, and it shows at a very high level how it works. Starting from the left, they have all of this input data. These are all the tweets. When you tweet about, how amazing Elon Musk is, how much you love the Tesla Cybertruck, like that is your input. Those need to go through a series of refinement steps, because when someone is scrolling through the feed, you don't want to just be hitting the database, hitting the universe of possible tweets. No, that's going to take way, way too long to do. So you have to do a certain amount of pre-processing, and they call this whole thing the pipeline. A certain amount of pre-processing to make sure that when someone is actually scrolling through, that what is shown to them is actually going to be relevant. And there's some really interesting ways that they have sort of segmented out this pipeline. The first is that they call sourcing, and they try to figure out what are the best tweets that you might find interesting. Next, they go through and they take those tweets and then they rank them. And then they run heuristics on that, which I said heuristicing because everything else is a gerund. That's what ing is, by the way. It's called a gerund. One of the interesting pieces of useless information that I know. They have to rank those. They have to filter out content for things that you've blocked, authors that you explicitly have muted or don't follow. They also have to make sure that you're not seeing the same tweet over and over again. And they also have to make sure that you're not seeing the tweets from the exact same author, because that's boring. You want to mix when you're on Twitter. You want to get out there. You want to see a lot of different content. You want to be able to, get really like angry at the content. That's all part of their game. That's all what they do. So their goal is when a pipeline runs, when someone requests a new batch of tweets that they want to see on their timeline, they go through and they get just 1,500 tweets. And it's a mix of both in-network and out-of-network. In-network are people that you explicitly follow. And out-of-network are people that they think you might want to follow, people that might be trending. It's a 50-50 match. It depends also on the user. They're always A/B testing out. But roughly, I think you could say it's a 50-50. So for in-network, what they do is they use linear regression to figure out what is the probability if I show you this tweet that you will interact with it in some way. Maybe that is a like or a thumbs up. Maybe you're going to comment and add to it. Maybe you're going to retweet it, and getting it close as possible to that, line of regression. That's what they're after when they're looking for in-network. So they're looking for engagement. Out of network is a bit tougher because you have so many millions of tweets. How do you pick the ones? So there's a couple different ways that they've done it. One of them is it looks for what tweets did people that I follow engage with. So this is where you get your sort of social network, your group, your cliques, what have you. And then they also look for if someone has similar interests to me, what are the things that they are interacting with? And this is under their GraphJet offering, and I'll kind of go into some of the code later. But for out of network, that's only 15% of their home timeline tweets, which if you remember, out of network is approximately 15. So then we're left with what's the other 35% that they're looking at? That's what they call SIM clusters. I kind of talked about it a little bit, but how this works is there's a given topic that someone is talking about. Maybe you're talking about Cybertrucks. Maybe you're talking about DeLoreans. I talk about DeLoreans all the time. So they have gone through and they've pre-processed and they figured out who are influential users that talk about the topics that you also talk about, but you don't follow them yet. And out of the universe of possible topics, they have found 145,000 different communities. Some communities are rather small. Maybe you're into antique repair of washing machines from the early 1900s. I'm sure there's probably at least 4 or 5 people that are interested in that topic, but there's not a lot of them. Some communities, oh good, my dad's procedure is over, and it went well. Awesome. Good news. Good way to have it LinkedIn Live. You heard it here first. Rex Gardner is doing well. So you have 145,000 communities. Some of them are very large. Some of them are very small. And this is a visualization. Oh, come on, click. There we go. Some of them are, if you're interested in the news, like the AP, the Journal, the Times, like those are all things that are going to be, like in that sphere of influence. Soccer, you're going to follow Lionel Messi. You're going to follow, Gareth Bale. I haven't thought about that dude in a minute. So it can tell based on either your tweets mixed in with things that you're interacting with. It tries to guess which community you're wanting to become a part of. And influential users are the way to keep you hooked. All of these have the little check mark next to them. I wonder how many people actually still have that check mark. But anyway, so now we have our 1,500 tweets. Half of them coming from people that we explicitly follow, half of them coming from people that we don't explicitly follow, but they think that we might want to follow it. Now it has to rank them. And this is where the machine learning piece of it comes in. They have a neural network where they have, it's kind of like that Arnold Schwarzenegger, a neural network. It's my terrible Arnold Schwarzenegger impression, where they rank, and then there's 10 score labels of each candidate tweet, and then they just say, whatever the highest score is, that one's shown first. Then they run through a number of heuristics. So heuristics, as I know from my computer science class, are different than algorithms. Algorithms are deterministic, whereas heuristics are non-deterministic. It's sort of like, it'll probably get you, half of the way there. That's fine. It is what it is. So there's a lot of things that they have to do. Visibility. Anyone that you have explicitly blocked or muted, those tweets fall off, which it's actually, just as kind of an aside as an architect here, it's interesting to me that they do this after they have run it through the machine learning neural network. I would actually do that on the sourcing phase of it, because if you've explicitly blocked someone, if you have explicitly removed someone, why include their tweets in the 1,500 candidate set only to have them filtered out before you're displayed to the end user? Like, why not do it at the beginning? One could be is that maybe it's computationally expensive to do it at the beginning, so they've actually moved it to this layer. That's my best guess, just as an architect. I don't, maybe there's another reason for it. I'm not seeing it when I came up with this presentation. Diversity, they want to make sure that you're seeing tweets from a lot of different authors. Again, the balancing, they call this out in the heuristic phase, but it's really something on the sourcing phase, so I don't know why they included it in here. Social, conversation, and then edited. So there's a lot of things that they run through to try to figure out, of these tweets, can I refine them just a little bit more? And then they get into mixing. Mixing is what is responsible for showing you content from people that you follow, people that you don't follow, and then figuring out what the right balance is, essentially, to show you the ads. So that's the whole pipeline, folks. Let me scroll back to where it is. We went all the way from, you're you're seeing this on the other side. We went all the way from the data side through the mixer to actually showing you people you follow, advertisements, as well as your out of network. So the next question is, let's see the code. Let's go through and let's figure out what this code actually looks like. In terms of what they used in that repository, surprisingly, a lot of it was Scala, which is a very Java-like language. It was built a lot for high concurrency, high throughput, being able to leverage multiple threads. Very good at large amounts of real-time or near real-time data processing. A sprinkling of other ones. A lot of their machine learning is in Python. Starlark and Thrift are ones that I have never heard of before. So that was kind of cool. When you go into their repository, you'll see this source algorithm. This is where they have it divided up, essentially based on the large use cases. I think Thrift, is that the one? There was one of them that was a build. No. That's a different one. There's a different one that I'm thinking of. So you want to explore. And you want to start with, obviously, sourcing, because that was the very beginning of the whole process. It's how we pick out the 1,500s. There are two major algorithms that I found that they're using to run the real graph, which is their in-network. There's, some slight difference between the two. One of them is a big query table, the other are data flow jobs, which seemed Google Cloud to me, even though I didn't think this was running on Google Cloud, but I don't know. We'll see. So at the very beginning of the process, we're sourcing our in-network tweets. It's actually running a SQL query, which does kind of make sense. And you'll notice that they have some things like this is like a screenshot from their GitHub. They have the database, Twitter, BigQuery, TweetScore, pub prod user information. So they actually have that, hard coded into their SQL, which database it wants to pull from, which is an interesting approach. That's not one that I would typically go with, but still, it's interesting. SQL is actually a good candidate for this portion. SQL is really good at being able to take massive amounts of data, and as long as you're writing your query right, as long as you got your indexes right, it is able to aggregate a lot of that information for you. You could try to load this all into memory, but I wouldn't really recommend it. So that's how the BQE works. It's 4 or 5 SQL scripts, if I remember right. This is just one of them. And it builds a candidate graph, produces a score for the tweets that it finds. The other one, Skyo, I think that's what it is. It does, it's machine learn. It uses Scala, which is, machine compiled instead of Java, which is machine interpreted. It uses Bazel that's what I was thinking of. It was Bazel. So because they have a very heterogeneous system in terms of the code, they have to make sure that they build it correctly and then they test it correctly. And there's a lot of different platforms that I have to support. So if you're going like with NuGet, or MS Build, that's specific to C#. If you're going with Maven or what's the other one, Groovy, that's specific to Java. Bazel or Bazel, I don't know how you say it, kind of takes one step back and it's the abstraction layer on top of that. So that was one of the things that I found interesting. I had never really run across that before. This is one of the pieces of example code that I found in Skyo or Skio. I wish these came with a pronunciation guide and this is Scala, by the way. So from the function, I can tell I am getting who mutually follows people. It compares your source and your destination, which I'm assuming the source is me. The destination is someone that it's checking to see if I follow. And then it figures out like how close we are together. So, nothing crazy. I mean, we can kind of figure this out as we're going along, nothing too crazy. And those are the two that really constitute the in-network. The out-of-network one, it does graph processing. So a graph essentially is pretend all the people that you know in your life are nodes on a graph, and there are connections between each of them for when they know each other. So maybe your best friend from middle school doesn't know the person that you grew up next to. Like, you are the link between the two. And what I found that was really interesting is that when it's doing this path workflow, it's actually loading all of that stuff into memory on a single server, but it's graphically indexing them over a sliding window because your followers change over time, things that you're interested in change out of time. And if you have something on a single server in memory, you can do computations very, very quickly. It's why it's called RAM. It's there for us to use. Now, some people at this point will complain, well, that doesn't scale. You want to go with something like Hadoop or something, kind of nerds pushing up their glasses. I'm a nerd with the glasses, so I can say that. I got my nerd carrying card, somewhere on my desk. That's okay. Because with being able to do distributed computing, there are certain things that you have to sacrifice. You have to worry about network latency. You have to worry about, things going up, things going down. So if you can get all of your pieces of your node in the same piece of RAM, I mean, it could be, multiple pieces of RAM on the same machine, but on one single server for it to just quickly be like, aha, I see all the connections, then you don't really need it to scale. which I thought that was kind of interesting. There's subsequent ones that I want to, subsequent one of these sessions I want to do specifically on some of those offerings. I just find it fascinating, some of the tools that they had to come up with to be able to support a lot of this stuff. So they are using servlets, which it's been a minute since I've seen servlets. This is what some of the GraphJet code looks like. And it's a little hacky. I mean, so you can tell from this. So they're looking at the top hashtags that I think the user follows. They iterate through the list of hashtags that they follow, and it's generating, you can kind of see it there, it's generating a JSON string instead of creating a new object, filling it with properties, and then serializing it. Now, there are some legitimate reasons to do this. Every single object that you create, you're going to have to worry about its life cycle. You're going to have to worry about when you want to eventually dispose of it. And that's where garbage collection comes into play. If you have things like garbage collection where you're not explicitly, dereferencing these things, being able to clean them up, you're really deferring to whatever the garbage collector wants to do. And you can have pauses where the framework or the library that you're using will suspend work on a particular thread, garbage clean everything that no longer has a reference, and then resume the work, which can cause, if you're doing a game, kind of like a stuttering effect, unless you're using, buffer double rendering. So there are actually legitimately good reasons for using this style of generating a JSON string. One of the other advantages is that this piece of it, you could actually pull that out into a constant variable so that it's not having to create a new one of these every single time this function is called. The compiler, the interpreter, actually I should say, since this is Java, though I would be surprised if the just-in-time interpreter didn't automatically do that. But there are some things that your compiler will do for you, but come on, people. Compilers have a hard enough job as it is. Let's make their life a little bit easier. Now, the other piece of it, along with GraphJet for the out-of-network one, is this sim clusters thing. I looked through the README. It's been a while since I've done any matrix algebra. I don't know. I don't quite understand this piece of it, but that's okay. I'm sure there are people that do. But I was able to at least go in. I could see, all right, I got my object. It's interested in. These are things that I'm interested in. What's the score for people that I follow? What's the score for things that I favorited? What's the logarithm of it? And what's the social proof, which I think that's, how big that cluster is in terms of the people that I follow. And it runs through this and it's like, okay, if I had to produce this from scratch, I would need a lot more time to really understand what they're doing. But I'm like, okay, sure, that's fine. You're doing some matrix multiplication, totally fine. So now we have our sources, we have our out of network and our in network, and then we have to rank them. One of the things that I found that was actually really interesting as part of this is they had a paper, an academic paper called MaskNet. And what MaskNet does is it tries to predict the CTR or the click-through rate, which is, if I show you a piece of content with a link in it, how likely are you to be able to go and click that link and then, either stay on my site or potentially go off? But the click-throughs at least indicate that there's some sort of human-based intention to learn more. It's an interaction. It's above an impression. It's like, I've actually got someone to engage on it. And in order to predict, based on the rankings of all these tweets, if you're going to click through, there's 10 parameters that I talked about earlier that they used. And this was actually, I'll pause for a second. This was one of the absolute most illuminating pieces for me. Because, I have always learned from, my time on LinkedIn that there's a certain amount of things that you can control and things that you can't control. I can't control how many people are on this live stream at any given time. I can't control directly how many people are watching this live stream. I can control what I send out. I can control the people that I interact with. And when people interact with my content, I can control how I interact with those people through subsequent interactions. So you'll notice that on any given tweet, this is the algorithm. I mean, I'm sure there's other things that they use in terms of how fresh it is. I think that gets into more of the heuristics. But if I'm just going to rank these 1,500 tweets, if someone favorites a tweet, that's only worth zero point 0.5 points. Whereas if someone just, I'm telling kind of based on the name of this variable, if someone replies to my tweet and then the author, I being the author, engage them, that's worth 75 points. So think about that. If you're worried about how many favorites you're getting, that is worth next to nothing. I mean, that is like a fraction, if I did that right, a 0.5%, maybe even less than that, compared to when someone responds to your tweet and says, hey, this rocks, or hey, you're terrible. Simply interacting with that person bumps you way, 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 way up. So just replying is good, but you have to then take the next step. So both of these things together, getting a reply and then you engaging with that reply, I mean, that's almost 100 points compared to 0.5. And there are some things that you want to make sure that you're not doing. One is that if people do the thumbs down, that's bad. That is so much more inimical than the other side for someone favoriting it. So you want to avoid as much as you can people giving you negative feedback. And then if someone reports you, I mean, that's like a math.min. Like that's about as bad as you can get. It takes a lot of effort to be able to come back from how much you can engage with someone to when someone reports you. Like one bad report, like that's gonna make the whole thing terrible. So avoid reporting if you can. And when someone replies to something that you put out, make sure to reply back to them. It's not just for a ranking. It's honestly for just, we're on these social networks to interact with people. We are supposed to be social. It's sort of in the name. So just when someone replies to you, just be nice to them. Like, give them back. So so we think about the pipeline from the beginning. We got our sourcing, we got our ranking, and now we got to do our heuristics. There were some really interesting things that I found in here. I'm really excited to show you all some of the stuff that I found. So as far as I could tell, there were a number of libraries that were around this, but Visibility Lit was sort of the main one that they had. And this is where they have to enforce things because Twitter it's a global product. There are certain laws and regulations in certain countries that they have to follow that are different from other countries and other regulations and other laws. You even get into nuances in terms of what's the person's age? Do they have any disabilities? Like there's a lot of stuff that you have to account for. So you have to make sure that whatever jurisdiction that the user not even is from, but what jurisdiction they are currently in, that you were abiding by all the local laws and regulations. And there were some really interesting, I think this is how I want to say it, geopolitical issues that I saw. You'll notice Ukraine was on the list. So they were able to identify, people that were talking about Ukraine. And I can't confirm or deny this, but I think there are some Slavic countries where they might have been told by the government to, kind of not show that content as much, which like when technology borders on reality, like things that we actually do, I don't know. I find that like immensely intuitive, like and intriguing. Like some of the stuff that we actually did at the health system I was working for was, things around monkeypox and, COVID-19 was actually a big one for us. Like weight loss drugs in terms of Wegovy and Ozempic. Like, I don't know. I just really like when I get the opportunity to work on things that actually impact people in the real world. Some of the other things that I found were it had identified and it was able to rank certain things higher, sort of the visibility standpoint, if the author was Elon, which I think this code was written, if I remember reading about it right, before he purchased Twitter. So maybe they can have a little bit of grace that was given to them because they saw that, like Elon was maybe buying the company and they wanted things to go well, or maybe they wanted to, downplay it. I don't know. But it's just really interesting when you see your first name as a property on, candidates to mix the tweets. I think that's kind of interesting. And one of the things that they did actually get grief for when the source code came out was the fact that they were so it's a heuristic. It's not a algorithm. They were not able to say with 100% certainty that someone is a Democrat or someone is a Republican. Granted, I think that, former President Obama and President Biden, there was probably like a 99.99999% score that they were a Democrat. And then former President Trump, is probably, or George W. Bush, they're probably author as Republican as maybe like a 99.99999%. So again, unless someone manually assigned it, it was probably classified into those two stratospheres. And what they were able to do is say, well, content that is relevant to Democrats, and I know that the author of the tweet is a Democrat and the person that I'm running this pipeline for is also a Democrat, maybe I want to gear them more towards that content because that's going to keep them on the platform longer. Or maybe the opposite is true. Maybe the person whose timeline I am generating these tweets for is a Republican, and what really riles them up are tweets from Democrats. Like that gets them angry, and the same thing is true for Democrats, by the way, like 100% true. Because they're all about algorithms like this. They're all about keeping people engaged, keeping people on the platform for as long as they possibly can. So if you show people tweets either from their, so-called, glass, echo chamber, that will keep them on the platform. Maybe exposing them to some tweets that really anger them, like that will also keep them on the platform too. So again, I'm not commenting on, is this right or is this wrong? I'm simply just showing what I found when I went through their code base. I tried to figure out, what it is that they were doing. And there were some really interesting pieces that I found. So to kind of wrap the whole thing up, when you have a massive amount of scale like they do, there is a certain amount of pre-processing that it takes to make sure that users are able to efficiently interact with your system. If they tried to load all of these tweets live to run every single thing in memory on a single machine, like it would quickly fail. You'd get the fail whale if you're old enough like me to remember what the fail whale is. So you have to do a certain amount of background sort of pre-processing through, honestly, heuristics. I mean, we call it an algorithm, but what they're really doing is just taking their best guess. They're constantly tweaking the little levers that it takes to be able to get all this content out, to figure out, what are the things that people really like? Is shadow banning real? Are echo chambers real? I mean, maybe to a certain extent, but I think it's mostly around just how they have weighted certain pieces of their machine learning algorithm. What are the things that they incentivize? And remember, if nothing else, remember that interacting with people that reply to your content, that will boost you greatly. Like, make sure to do that if you're interested in getting your content shown. But at the end of the day, it's all about, pre-processing. So going back to the sourcing, running that through SQL, absolute great choice, able to do a lot of processing. You don't have to declare what you want. You can just kind of describe what you want. You don't have to write the code for it, and it knows how to get all that information for you effectively. Processing it through Scala and PyTorch, which is what their heavy ranker, I believe, is used. Also, very good choices. Python's great for machine learning. Scala is great for massively paralleled computing. All good choices. The in-network versus out-of-network, how they mix the two together, really good choice. There weren't a lot of things, honestly, that I would really complain about, mostly because I'm a dilettante. I have no knowledge of how these algorithms were developed. I have, some opinions, many opinions on what I might have done differently, but really it wasn't that much. Like I could definitely see where a lot of these authors were coming from. I could see why they made certain technical choices. Though I would say, if you can, avoid things like the Elon flag. I think that is, it's just kind of silly to have, I don't know, maybe this is me. But I found a lot of really interesting things when I went through here. And it honestly validated a lot of the things that I was thinking. Like I've worked on projects before where I have had to do a massive amount of pre-processing in order to get all this stuff to show. And it means that it is a eventually consistent system. It's not real time. It's not even maybe near real time. It's maybe, 5, maybe 10, maybe 15 seconds delayed. But that's okay because when you're working at the scale that places like LinkedIn are working at or places like Twitter working at, that's a sacrifice that you have to make. Distributed computing, which is going to be one of these LinkedIn lives, there are some real concerns. Being able to take into account latency, being able to take into account bandwidth, being able to take into account just the fact that you can't cheat the speed of light. Like there's just nothing you can do to get better than that. Those are all things that you have to take into account. And we as software architects have to be able to take a step back. We have to make sure that we're not just seeing the forest for the trees, but we're able to understand how data moves in a pipeline, make sure that there are pieces of it that we can adjust appropriately, and make sure that we're using the right technology for the right job. I wouldn't recommend running Scala on all this. I wouldn't recommend running Python on all this. Be able to pick individual pieces of your system that you know work well. And if you can do that efficiently, then maybe you can write the next Twitter. So again, my name is Zach Gardner. I'm the chief architect at Keyhole Software. Thank you very much for listening to me rant and rabble about the Twitter algorithm. I hope you've learned something. I certainly did when I went through this presentation. And I hope that one day I will see you all in the future. Cheers.